The last topic in chapter 8 is on angular momentum. Now, if you recall from way back in chapter 7, momentum is mass times velocity. Well, the angular momentum is equal to the moment of inertia, the rotational inertia, I, times the angular velocity, omega, although we frequently refer to that as W. So many radians per second. Now the other thing is, on page 8-11 of the textbook, you might take a look there and you see a young lady, and she's on ice skates, I guess it's ice skates. And what she's doing is she's going in a little rotation like this, and she brings her arms and legs close together and she speeds up. That's angular momentum. So we need to use a formula for angular momentum, and this is called conservation of angular momentum. And what this says is the initial inertia, initial rotational inertia, times the initial angular velocity is equal to the final moment of inertia times the final angular velocity. Like that. Now what happens here in this particular case, here's a young lady, this is my diagram, there's a better one in the book, and what she's doing, she's going that little circle. When her arms are out like that, they have greater moment of inertia. It's like mr squared, and when you bring the radius in and make the radius smaller, then the moment of inertia will decrease. When the moment of inertia decreases, then something has to happen, and what happens is the angular velocity will increase. So the only problem we're going to worry about on angular momentum, at least in this little lecture, is on page 8-16, and it's problem number 24. And this problem says, a student stands on a platform which is rotating at 6.3 radians per second. When the student draws her arms and legs close to her torso, her moment of inertia will decreases from 3 kilogram meters squared to 0.8 kilogram meters squared. Determine her final angular velocity in radians per second. So we have to read the problem again. It says the student stands on a platform which is rotating at 6.3 radians per second. Well, that's 6.3 radians per second. All right. And it says the student has a moment of inertia of 3 kilogram meters squared. Then she draws her arms in closer, and what happens is the R goes down, so the moment of inertia is also going to go down, and it says it decreases to 0.8 kilogram meters squared. And now what we have to do is we have to figure out what the final angular velocity is going to be. So now we get out our calculator and we figure out 3 times 6.3 should be 18.9, but let me make sure that I don't make mistakes. 18.9, that's correct. So this is 18.9, kilogram meter squared radians per second. And so over here we have 0.8 kilograms meter squared times the final angular velocity. Now what I'm going to do is divide both sides by 0.8. So when I do that, I have 18.9 kilogram meter squared divided by 0.8 kilogram meter squared. And this is radians per second up here. And there's your final angular velocity. So 18.9 divided by 0.8, and that comes out to about 23.6. And so the final angular velocity is 23.6 radians per second. And that's the end.